R equals delta T divided by Q. What does that have to do with the sleeping pad? The change in temperature divided by the heat flux. Okay. This particular sleeping pad, the Thermarest Z-Lite, has an R value of 1.7. The Nemo switchback, very similar, is 2. And the REI trail brake is 5. So what do those numbers mean? The test for the R value is in a controlled environment where the heat pad sits in the middle. Delta T is defined as the difference in temperature between the hot side and the cold side. And Q is defined as the heat flux, or the rate at which the temperature transfers from one side to the other. R solves for how well that insulated pad keeps the hot side hot and insulated away from the cold. Delta T is fixed because you have a fixed controlled environment, pad's in the middle, the heat side is fixed, the cold side is fixed, the heat flux is value that you're measuring. If you have something close to 1, the heat transfer from one side is going to be relatively easy. That makes sense. This is super lightweight. It's thin. It adds a little bit of comfort, a little bit of insulation and reflectivity from the heat, but it doesn't really insulate well. Even if you can build up warmth with that super warm sleeping bag, you still have essentially that ice pack underneath you of the ground that's going to try to suck thermal energy away from your body. No matter how much heat you generate, if you have a high heat flux, you're still going to feel cold. So this one, R being 5.1 equals delta T in Celsius divided by watts per meter squared. Let's say you're camping in winter in the snow. You have an R value sleeping pad of 5.1. You and your sleeping bag are 33 degrees Celsius and the snow itself is 0 degrees Celsius. Delta T is 33 degrees Celsius. If you calculate for Q, or heat flux, you're losing 6.47 watts per meter squared. And that's relatively low, which is why 5.1 would be good for winter camping. Keep in mind, R values are additive, so you could take these two or all three of these. I think you'd probably get diminishing returns at a certain point, but you get the idea.